right, welcome to week 2 of distance learning. In this lesson, we will talk about section 6E, natural logarithms, section 6E, logarithmic equations, and section 6F, the change of base. I'm going to give a bonus point to whomever can identify the song being played in the background. Okay, enough for the music interlude. That actually should say identify the song and artist being played in the background. So let's go ahead and get started. I'm going to do this the same way I did last week. I've got a series of examples for you. I'll work them out. We'll explain them. There's going to be a little calculator thing that you're going to need to do because you are going to need to use your calculators as we start to move forward in this. So remember, in the last unit, we talked about that natural exponent, basically that letter E, that mathematical number E. Remember, E to the 1, if you use your calculator, is approximately 2.7183. Remember, it's an irrational number. So if you remember from the beginning of the year, irrational numbers cannot be written as rational numbers, hence the irrational piece. So they can't be written as a fraction of integers. They are usually non-repeating and non-terminating decimals. Irrational numbers are like the number pi, obviously now the number e, the root 2, etc. So last time we talked about the natural exponent, so we could talk about like e to the x is equal to some value y. Well, if we can have a base of e to some power is equal to y, then that means we're also going to end up having a natural logarithm. Notationally, what we end up seeing is that the natural log of e to the x is equal to x, and e to the natural log of x is equal to x. Now, pronunciation, you'll hear me say natural log. The natural logarithm is the ln. So natural logarithm is the ln of something. Again, remember, this comes from the fact that e to some power a is equal to some value b, which means if we write this as a logarithm, the log of b base e is equal to the exponent. Because remember, again, when we have a logarithm is an exponent. So notationally, though, we don't write log of base e. We will write the ln of b is equal to a. And those two things mean the exact same thing, except you will never see, I say never, but I want to hesitate because you may see it. You will not see people write log of b base e. You will see them write ln of b is equal to a. So the laws for natural logarithms. The laws for natural logarithms is the same as the logarithms for any other base, like base 10, base 2, base 3, base whatever. If we add two natural logs together, it's the same as the product of those two. If we subtract them, it's the same as the quotient. And constant times a natural log of b is equal to the natural log of b to the power of that constant. So these laws are the same. What does this look like? Well, let's take these three examples. In letter A, we have the ln of e to the 3. As we have talked about the fact that natural log or logarithms are just exponents, the ln and e have the same base. So the ln of e to the 3 is just the exponent. What is the exponent? The exponent is 3. Now, again, remember, you can always pause these videos, try to do the math, and then come back and unpause the video and watch it. I'm not going to pause because otherwise that'll make the video like 18 million hours long. And we all know you don't want to need an 18 million long hour video. So, letter B. Take a second, rewrite that using an exponent. Pause if you need to. But square root or a radical is your fractional exponent. So again, when we take the log of e, so again, same base. Since they have the same base, the answer is just the exponent, which is 1/2. Now, there's a couple of different ways to look at letter C. I like the fact that we could take and use our rules of exponent and rewrite this as e to the ln of 5 squared using our rules or laws of exponents. Now, looking at that, it's e to the ln of 25. Now, if we went back up to those notation, e to the ln of x, because again, they have the same base, they undo each other, the answer is just 25. Okay? So, what do they look like if they get a little bit more complicated? Let's call this one letter C or letter D. So this one, if we did the same thing, we would have e to the ln of 2 to the power of -2, which would give us e to the ln of 1 over 2 squared. Now again, I'm doing step by step. Some of us may be able to skip that step in our head and say that this is just 1/4, and we end up with an answer of 1/4. Again, anytime you need to, pause, try the problem, and go back to the video. I actually have 2 different ways to do letter E. I see this as a power to a power, and the last time I checked, power to a power is going to be e to the a times b. Now, again, same base. So since the bases are the same, my answer is the exponent, which is a times b. There's one way to look at each other. We could look at it from the rules of exponents and just say, okay, well, that's b ln of e to the a, which we know, which is b times a times the ln of e, not ln of 2, ln of e. Now, again, same base, so that answer is 1. So we end up with b times a times 1, which is just ab. Again, 2 ways to look at the same problem. So, calculator time. Find x if the ln of x is 2.17. So I'm going to rewrite this as an exponential. Rewriting this as an exponential. What's my base? My base is e. What's my exponent? 2.17. And that is equal to what I'm taking the natural log of, which is x. Now, all I'm going to do is enter that into my calculator, and you will be happy to know that I downloaded Desmos scientific calculator. So I now have a calculator on the iPad, which I can show you. So I'm literally going to type in e function, e to the x, and I have what, 2.17. So I go back to the main screen, 2.17, and hit enter, and 8.76 would be my answer. So e to the 2.17 is 8.76. Again, that's an approximation, so I am going to use my squiggly equal sign. You can do the same thing with the second one. What's the base? E exponent negative 0.384 equals x. Using your scientific calculator, function e, oh no, clear. That's so e to the negative 0.384. Answer is 0.681. Again, approximations. So now, just like in the last section, I asked you to use those laws of logarithms to write them as a single logarithm. This one is addition. So when we add, we rewrite it as, good guess, multiplication. See, I knew you guys could do this, which is just the ln of 15. Subtraction, we rewrite it as a single log. This time it's going to be, bingo, division, 24 divided by 8, which is the ln of 3. And this is the one that sometimes causes problems. We need to remember we have ln of 5 minus, what can I rewrite the 1? 1 times the ln of e, same base. ln is base e and e is base e. Subtraction means that we rewrite it as a division in a single logarithm. So we're going to do 5 divided by e. And yes, e is a number, so you can treat it just like everything else. And we can write it as e, 5 divided by e. So again, now we're into that process of rewriting as a single logarithm. All right. Use the laws of logs to simplify. Again, we are just using those laws. So that 2 is going to become an exponent. So the ln of 7 squared minus the ln of 2 cubed. Now I'm going to take all liberties and rewrite every single step. The subtraction means that we take the 2 logs and we divide what we're taking the log of. So that one would be simplified as ln of 49 divided by 8. Again, remember, pause the video, try the math, and then watch the video and see if you're doing it on the correct. So 2 ln of 3 becomes the ln of 3 squared plus 3 ln of e, because again, that's the times 1. 1 is that ninja thing that we multiply by. So we have the ln of 9 plus the ln of e cubed. Addition means that we change it into multiplication. So we're going to change it into multiplication. So ln of 9e cubed would be our simplified answer. Okay, and that's the end of section 6D. 6D. So on to section 6E, which is logarithmic equations. So, quick note, using the laws of logarithms to write equations in a different form is a useful way to find an unknown. The cool thing about log functions is they are one-to-one, and if you remember from our previous units, one-to-one means that for each x there's exactly one y, and for each y there's exactly one x. You can take the log of both sides of an equation without changing the solution, provided that both sides of the equation are positive, because logarithms have a domain of x is greater than 0. Okay, so the domain of a log function is that x is greater than 0, so therefore you can only take the log of positive things. So what does that look like? Well, take a look at letter A. If I have y is equal to a squared b, and I ask you to rewrite it as a log equation in base 10, we're going to do that thing that I talked about, which is take the log of both sides base 10. Now I'm not multiplying. It's kind of like taking the square root of both sides. We're not multiplying it by a square root symbol, we're actually doing the square root. So we're actually doing the logarithm of both sides. So that leaves me on the left side with the log of y, and on the right side, the log of a squared plus b. Now I'm going to expand that using my laws of logarithms, and I'm going to change that into, it's a product. Sorry, not plus sign. It's a product, so I'm going to change it into the log of a squared plus the log of b. I'm going to switch this first one with your exponential into 2 times the log of a plus the log of b, and that's equal to the log of y. Now again, all I'm asking you to do is write it as a logarithmic equation in base 10, so that's just an expansion piece there. We're done. So letter B, if I did letter B, same deal, p is equal to 20 divided by root n. Has to be positive on both sides because 20 divided by the square root of n, we're only looking at the positive number. So we are going to take the logarithm of both sides. Now, again, if I don't write a base, I do indicate this is base 10. So log of p base 10 is equal to the log of 20 divided by root n. Division means that I can change it into the subtraction of two logs. So the log of 20 minus the log of root n. I don't like that square root. I am going to change that radical into an exponential. And square root of n is n to the 1/2 power. We're going to pull that 1/2 out into the front. So we end up with log of 20 minus 1/2 log of n. Done. Okay. Now we can also use our laws to actually do some solving. So if I take and write these without logarithms, let's choose a new color. Let's go pink. All right, so I'm going to simplify the right-hand side. I'm going to leave log of a for right now. And I'm going to leave log of b plus log of c squared. Again, the coefficient becomes the exponent. Now it's a sum, and sums can be changed into the product. So the log of bc squared, which now has basically an equation sign. Basically, the log of a equals log of bc squared, which implies that a has to equal bc squared. Now, if we apply that same logic to the other one, it has a different base. It has a base 2. All right, so that's going to give me log of a cubed base 2 minus 2 log of 2 base 2. Not base b, base 2. Because remember, if we take the log of the same thing that it's the base, that's that 1. And 2 times 1 is allowed because those two things are equal to each other. Okay, so now I'm going to combine together and keep my log of m base 2 equals subtraction. So subtraction means that I need to eventually do division, but I got that coefficient first. So I'm going to change that coefficient and leave it as minus log of 2 squared base 2. Log of a cubed base 2 minus log of 4 base 2. Now I'm going to change that into your quotient in a log with base 2 of a cubed over 4. So therefore, what does m have to equal? Remember, 3 dots means therefore. M is equal to a cubed over 4. Nice work, guys. All right. 6C, change of base. All right, so let's do a little math. Let's solve the following equation by taking the log in base 10 of both sides. So we just did that. We just practiced that. We're going to take the log base 10 of this side and the log base 10 of this side. So where's that x going to go? Ding dong, you're right. It's going to go out to the front. It's going to become the coefficient of the log of a equals the log of b. And I'm solving for x, so both sides I'm going to divide by log of a. So that means x is equal to the log of b divided by the log of a. Now, why is that important? Well, that's important because that's actually what's called the change of base formula. If you look really carefully at your graphing calculators, you'll notice it only has log base 10 and the natural log, which is log base e. But we don't always just have things in base 10 or base e, so we need a way to convert that. Well, what that is called the change of base formula. And the change of base formula is the following. It says that if I take the log of a with any base b, I can change it into any other base that I want to, let's say c, by taking the log of a base c divided by the log of b base c. Now, why would this be important? Well, let's say I want the log of 5 base 2. Well, that's great, except for the fact that there's no base 2 on my calculator, at least as far as logs go. So what that means is I want to use base 10 or ln, something that's easy. So I'm just going to say, all right, I'm going to take the ln of my 5 and divide it by the ln of my 2. Remember, I did tell you I was probably going to use that ln more so than log, and that's because it's shorter to write. So if you do that, that's the same as taking the log of 5 base 2. Now you can also do it with log base 10 and take log of 5 divided by log of 2. If you wanted to, you could rewrite it as log of 5 base 3 divided by log of 2 base 3. But why would you do that? Because, again, it still doesn't help me with my calculator. So, example. This is exactly what we just did, except we were taking the log of 5. So if I want to take the log of 9 base 2, I'm actually going to take the log of the 9 and divide it by the log of 2. So the base goes on the bottom. If I did it with natural log, it would be ln of 9 divided by the ln of 2. Now, hopefully you can all use your graphing calculators to actually do that. How we've used this change of base formula because it allows us to do these logarithms with base 10 and base e. However, through the advent of technology, there is actually a log base on your calculator. It's under math. You have to scroll all the way down to A. But I was really cool. Well, I don't know if I was really cool, but I want to show you something. I created a short YouTube video that I'm going to play for you right now. All right, so I'm recording a screen share to hopefully post into our notes of how to use your graphing calculator to use the change of base. So you can use the change of base formula that we just talked about, which is the log of what you're taking the log of divided by the log of the base. Or you can use your graphing calculator. So using the calculator, you can take the log of 9 divided by the log of 2. And when you get that, 3.1699, you can also do ln, so the natural log. Or under alpha window, remember that shortcut? There is a log base formula under number 5 that you can use. So you can plug in the base of 2 and substitute the 9, and you actually calculate the same thing. The other place you can locate that is under math. Now, as you notice, I scrolled down way too much because of getting it to actually work. But it's letter A under the math cap. Pause my video. All right, so it's under the letter A that you see the log base. It pulls up the same one as you'd get when you do alpha window with those shortcuts, and we talked about those shortcuts in the last thing, but it enters the same thing that we did previously, and that's basically entering the base of 2. So the calculator will do log, it'll give you the box and the box, so you can enter base of 2, enter the 9, but you end up each time with the same exact answer. So with that being said, I will post an additional slide that will have the homework because I didn't choose those problems yet, but I wanted to get this video recorded today prior to any craziness this weekend. Hope you guys are well. Please remember, log on to office hours if you are having questions. And if you're not 100% sure, ask Savannah and Arnav. It does help. And then I get to see your lovely faces because I'm not going to lie, I miss you guys. I miss teaching to real humans instead of hiding in my bathroom because that's the only place where nobody will bother me. Hope you guys are well. I miss you, and take care.